there a giant sweat stain on my back that formed gradually,
No.
like through the talk?
No.
Okay.
I enjoyed looking at your back.
For rocks. Yeah, that's right. That was neat.
Oh, I see. There was a Michigan State professor that he would just give lectures sitting in the back of the room just with a pointer. And I thought
Seriously?
That was, and I wish like
You could do that,
Yeah, like
yeah.
we could take a mic up there. That was what I was originally thinking.
What was its motivation?
Just being cool, I guess. Yeah? That's okay. It's unusual because there's so many of us. I think other roundtables didn't have so many people. I don't know why my Evernote is not starting. I'll just do it. What do you want? I think that this is supposed to be recorded. But you can also do that. It sounds good.
You're going to run this thing?
Should I? Okay. We can take turns.
In the first one, we kind of covered that, right?
Yeah. It was just a way to prod people into giving controversial opinions.
Normally we get through about 4.
Yeah, that was what I was worried about.
So you're gonna ask the questions and then like sort of like psychologist style.
That's what I usually do in meetings. All right. Let's begin. We have so many questions to get through. We're going to keep you guys here until we finish all of them. We are going to solve everything right now. And the first thing we're going to solve is we have the first 2 questions that we have are kind of related, and they're both sort of technical. And the rest of them are more about data sets and missions and recommendations and how those things can be improved. So there were a lot of talks that covered separating tectonic deformation from soil moisture in different terrains, in different landscapes. So the first and second question have to do with that. Do people, what have we learned from this meeting, from this past several days regarding how do we separate the tectonic deformation that we care about from the soil moisture effects that other people care about? Questions 1 and 2. Who would like to start? What are the best ways? In your opinion, what are the best ways? What do? Do you throw out interferograms you don't like entirely? Do you do some kind of modeling? If nobody has strong opinions, we'll just... You guys are like a high school class. Go ahead, Chris. 1 and 2.
Just to launch off of what John Elliott was talking about this morning, I'd love to. People might be already doing this, and I may have missed it, but have hey, is this a phase-biased pixel? Okay, ramp up the uncertainties on the deformation for people that want to use it for tectonics or for anything, I guess, kind of workflow. Where if you're less prone to, like Chi was showing the areas, and the Tian Shan is not prone to phase bias as much, but higher biomass areas, I think, are. So something sort of scaling on that, in addition to, the unwrapping and where you are, and then just other sources of error, which I guess could all be added formally.
So you're saying you could scale your uncertainties based on loop closure or non-closure?
Yeah, some of the stuff in Western Anatolia in mine, I'd love to just put infinite uncertainty on some of the things that look like phase bias so that the model doesn't try to fit it and no interpretation does.
And would you do that by hand or?
Well, ideally not, because I'd probably screw it up.
Okay, yes? Oh yeah, we have microphones.
So we did a good test of just taking out the shortest and then the next shortest, so you can identify the most vulnerable pixels. That's a quick and dirty way. And then we've done these more seasonal, sort of longer interferograms of Tian Shan and then there's empirical corrections that have been done by others, and then hopefully get to a physical understanding of what's actually driving these would be the ultimate goal, rather than having to throw stuff away or empirically guess it. Is actually, as a community, can we understand a bit more about the earth or vegetation and soil moisture? That would be the end goal. I think Rowena, I missed it because I wasn't here, but Rowena showed something as well. It's pushing towards that.
Yep. Yeah, some people were commenting that the soil moisture and things, those effects are not necessarily noise that we need to get rid of, but a signal that we need to understand. Signal that we need to get rid of. Okay. Great comments. Any other comments?
If I could just make one comment. I mean, I guess we discussed this, if those were at the previous session this morning, we discussed this quite a lot, and I guess it was a move towards having a workshop on this. So I mean, I guess we could reinforce that if we think that's a good idea.
Since we're encouraged to give recommendations, so this is a recommendation to have a workshop.
And a test area study.
I mean, there's a corollary to that then. Are we worried if we go back to 6-day interferograms, are ESA wasting their time for certain areas of the world, or we still want to keep encouraging ever shorter? And then what happens when we do get to daily interferograms? Are we going to be more worried?
Right. We really want that frequent repeat, but it sounds like it can also be problematic. And does it get more problematic as we make it even frequenter? Scary question.
You know, I think Charlie Warner, someone showed an interferometric analysis of only sequential pairs of interferograms that really highlighted the soil moisture effects. It didn't look like tectonics at all. I don't know if anybody remembered that analysis, but I think it was in California. So that's one way to isolate the soil moisture part, right? Just sequential interferogram time series.
And then remove it if that is not
Well, not
what you're
remove it,
interested in, but
understand it.
Understand. And then okay, great. All great suggestions. Anyone? PCA methods, AI. All right. That would be that's all good ideas. Okay. If there are no other suggestions, if there are other suggestions, we can talk about it more. If not, we can move on to the more general questions, I think. Okay. So this is a hugely general question, number 3. What scientific advances do you envision will drive our community, the fringe community, in the future? If you were to dream and imagine what you're going to do, what you want to do. Okay.
An understanding that the Earth deforms in a north-south direction.
Well, then you need a left-looking SAR and a right-looking SAR. They're simultaneous. North-looking SAR.
You have to make sure they don't collide.
What else? Sorry, struggling with notes.
So it's very nice to see this specialized INSAR stuff that we do, but sometimes I have the feeling we should connect more with other sciences. I mean, I'm trying to do this with seismology, and I saw we have this nice automatic systems coming up. But I think it would be so much meaningful if seismic data would be included right away. So there are things yeah, I think we could look out also more for other products for these worldwide to really integrate what there is. Yeah. So I'm not sure if I'm now really overlooking a lot of efforts that are done already, but I think this is I think where we will gain a lot.
I think that's a great point. So seismology, seismological studies is one. What else?
Seismology is one thing that it's just a very small point and very concrete on the topic of the damage maps, for instance, Sang-Ho. There is a Copernicus build-up area layer, yeah, where you have 4 pixels, you know how much percentage build-up layer is. And one could use the damage maps to combine this to say, okay, we have damage where people live or where there's infrastructure, and then we have damage in like rocks. It could also be important because it can block roads and landslides and so on. But I think then these like damage our products, which is an INSA product. Yeah, when we combine this with something else, it could be so much more useful. And if this is combined by someone who knows, like also limitations maybe of INSA damage maps. Yeah, so this is something where I see links that we may miss at the moment.
Sorry, combining damage maps with what?
Yeah, with population. Yeah, we call it like exposure data maybe. I also, because I was playing with this a bit, we have blind spots, right, in these damage maps. We should communicate that. So there are areas that are never coherent, and I at least maybe I'm doing it the wrong way.
For those land cover type that has persistent low coherence, you can use intensity information, and it seems to work well. One of the things that Eleanor is doing is to combining joint methods to utilize both coherence and intensity correlation in a way that you don't have to choose one of each depending on the land cover type, but to combine them so it always produces optimal performance.
So I'm stopping here because I don't want to offend anyone by overlooking things. But I think in general we should.
Well, a data set that makes sense to auto-combine is optical. Like if somebody can fly over optical imagery, and then that can be I mean, there's probably a bunch of methods for doing that. But yeah.
Speaking of damage proximate, for this Morocco earthquake, I noticed that Lixar deformation map was produced quite quickly. And I haven't looked into details how to further, is there a way to reduce the latency? Because primarily because our processing time was the major contribution to the latency, but we got to the point now where even time series analysis, it takes only a few hours to generate that. Highlighting the latency from satellite to from ESA's Sci-Hub to show up. I wonder if Lixar has faster routes?
No, I think we use essentially the public access, but the biggest delay, I think, is obviously the earthquake to the overpass, usually, at the moment. So I think the biggest thing that would make a difference would be more satellites, more publicly available data sets, whether that's commercial providers opening up their data sets kind of in a routine way or acquiring data after an event. I'm involved in a Earth Explorer 12 proposal, and I think some others probably in the room might be as well, for a geosynchronous SAR that would basically enable you to make a 24-hour interferogram potentially every hour, but it obviously you don't get global coverage. You stare at smaller areas. It also gives you a different look geometry. So I think there's that latency. But I think by the time we've got Sentinel next generation, or Sentinel-1, we've got 2 Sentinel-1As.
Right.
1A and 1C or whatever it is. And we've got Roselle-1 and Roselle-2 and NISAR and whatever follows NISAR. Maybe the Japanese can open up the data sets as well. I didn't know that.
That's happening,
yeah. So all these things could, so sort of systems of systems that aren't just reliant on one satellite, that are actually genuine. Take whatever you can get. And that would be quite exciting. Eric?
Yeah, and along that line, I think it would be good to recommend that the commercial, new commercial satellites establish some kind of background acquisitions, because they can acquire data after an event, but if there's no pre-event image, we can't use it for any kind of change detection or interferogram or anything.
Yeah. Yeah, they didn't, for the Turkey earthquake, for example, there was a very nice one-day post-seismic interferogram, but there was nothing spanning the earthquake. That was from ISI.
And if we could use the opportunity to continue to recommend that ESA launch 1C as soon as possible, because it impacts both the science and then also some of these response mechanisms. So for many of these points, just reiterated.
Just to change the topic slightly, I think one longer term thing that's going to be more and more apparent, it's already apparent in some of the talks at this meeting, is that we've been trying to get these static interseismic deformation maps, but the Earth really isn't static, and there was a nice presentation on Ecuador that showed that kind of really a sort of long-term change in the velocities before and after the earthquake, and we've seen that as well. There's saw in my presentation, you get these very long-lived post-seismic transients. So there's a lot of things, the thought of David's presentation on California, where it's one of the fundamental assumptions there, I think, when you're turning the strain into hazard, is that that's a kind of static strain rate, and it probably isn't. So
maybe moving all this to time velocity.
Yeah, and particularly exploiting, as the Sentinel time series gets longer, we've still got the ENVISAT data, we've still got the ERS data. It's really, really difficult to use those old data sets. Natalie gave a presentation, but it's really, for example, they've deleted a whole bunch of ERS data that was perfectly usable because it had a few percent missing lines and didn't meet some quality. And so we couldn't find them, but for the Grosvenor earthquake, we couldn't find, even though...
And they changed the data format.
Change the data format, it's all these things. Anyway, it becomes, so actually also, maybe it is a recommendation to make sure, at least with Sentinel, we preserve that archive and don't delete stuff.
Yeah, we'll also not delete any other ERS.
Don't delete anything else.
Change.
What's LP? Oh, right, Vine. Vine would be good. I'm a cassette
what that
person,
means.
really. You can get it all on cassette. Back an exabyte. I know. We looked in all the cupboards for the Grosvenor data. I asked people in France. I know CGG, when they were MPA, they processed it. Sorry, this is anecdotes, it's not relevant. But they just threw it all away because it's all online. And it isn't. Well, they won't. Did you check that they were all online before you did it? No, there we go. They won't be. It is sad.
That old Ethernet cable.
But anyway, I do think that data preservation of these long-term archives, because you don't know when it's going to be important.
So that kind of that's a good segue into our next question, which is that what are your biggest challenges when you're trying to do your research using the SAR data that exists today? And what we kind of covered some of this already. We don't have maybe enough satellites. We don't have as much of an integrated system of systems that we would like to have. Maybe we could incorporate other data sets. Data set challenges. What are your biggest challenges now using INSAR? And what would you change? What would you like, if you can dream? What measurements are missing? Or what, yeah.
That's an LOS ambiguity. Where that guy was.
I think the reference frame issue is important when it comes to the large scale tectonic studies. Because I remember when we were working for Iran, there were different GPS studies. They were all saying our velocity fields, this is based on Eurasia fixed. And how different the studies, they fixed the Eurasia. It was different. So we should be careful. This is one of the challenges when we get the GPS velocities. Firstly, we should see if they are unique. They have a unified reference frame in Eurasia. And then we go and then use them as a constraint for INSAR. Maybe Tim and his colleagues, they have done this, but if not, maybe in other studies also, we should be careful. We use Eurasia fixed GPS velocities and different reference frames, but this is also part of challenge.
That's a great point. Any others?
I think I'd applaud your initiative. I don't know whether this is relevant to this question or another one, but something we can encourage. Maybe ESA could fund a comparison study because it's really important. These comparisons of different processing chains, and you learn a lot from them. But it's kind of dull, isn't it? Nobody really. It's much more interesting. I mean, it's much more. Sorry.
Every Thursday at 3 p.m.
Every Thursday.
Midnight tonight.
Okay. Right. Guess what I mean. Your work and you presented it beautifully.
Thanks.
But what I mean is, it's much more interesting to process a new area and get a new exciting result than to do actually the really important work of working out what we're doing wrong and learning from best practice.
Well, yeah, it's dull until it isn't. Like all of Jan Kagan's statistical seismology papers are like the most useful papers now, and I don't think anybody else, maybe 2 other people, wanted to work on that stuff when he was doing it. Yeah, it pays dividends.
It's okay. I wrote that down in the nicest possible way.
Thank you.
I'll try and help Tim and move this on. So a challenge, at the moment, we're sort of working in a batch mode. We've got our archive, it's almost a 10-year-old archive now. So we run it, for instance, to get our long-term velocities, and we'll produce velocities from that batch data. But the challenge now will be, how do we continuously update this without starting from scratch? How can we learn from the GNSS community to get the time series? The approach we certainly adopt at the moment, you end up doing it again. But can you do that in near real time, or do you wait until the next PhD student does a batch of 4 years? It's how we address it as a community, how to keep it updated without it being a monumental effort to redo it.
Yeah. And you get down a certain route with an approach, and you think actually if you're starting from scratch, you probably start it a different way. But reprocessing 1.3 million interferons or whatever, it's not. Yeah, it's a big job to start again. But there are lots of other approaches for processing that have been proposed, and the idea of doing these corrected, what we call these SLCs that are geocoded, INSAR ready SLCs, and so different ways of doing it. I think that probably weren't around when we started our system, but that people are doing now, and I think maybe are faster for reprocessing as well.
Well, aligned to that is the ARD analysis ready data sets. Some of ours, we try and provide stuff, but I wouldn't say people say it's ARD. And there's quite a few initiatives who see us to try and do that, and I don't think we're there as a community.
Well, good points. Any other comments on this question? Data sets? Number 4, technically, we've talked a lot about different things. So challenges that you face in terms of the data sets that you have to use, whatever that means to you. Yes?
I'm not sure if anyone has looked at this. So we have now, as I learned from plots, not from my own experience, that there are larger baselines now for Sentinel-1A because of some problem. And do we know how much this affects coherence? Because there's also this want from other communities, of course, to increase the baselines. And so I'm just wondering a bit if we could make a comment that we would like to still have like small baselines for coherence and frequent revisit and so on. But it would be very interesting actually to see if it has an effect. I mean, it comes on top of losing 1B.
Yeah, I think we should make that point, that we want to keep the shorter baselines, and ESA is already thinking about that. It's the solar cycle that's increasing the baselines, and they talked about perturbing the orbit more often, although then it shortens the whole span of the satellite. But still, we should say something about keeping baselines within 300 meters.
Yeah, maybe for this, so I guess it's about like height estimations for other communities with the longer baselines. But now the question is, are like 500-meter tube, is this helping or is that not helping? Is that enough? Well, so
They can get their own satellites. Nothing? No.
So we are happy for them.
Yeah, similarly, I think I raised this on Monday about, for Sentinel-1 Next Generation, this idea that you could, or for Roselle, I think they're thinking about having a bigger overlap between the bursts that would allow you to get the north-south out. But it seems, they don't seem particularly keen on it. But Andy, you know more about it.
Yeah, well, so actually, I think potentially it's possible for next generation as well.
Okay.
So I think we should make the recommendation for both Roselle and NG that they do it.
Yeah, certainly for our community. I mean, they said, oh, we've got to balance communities, but if we don't actually at least ask for what we want, then there's no chances, let's say.
It's when we're up against the Copernicus service.
Yeah. But if you get 3D data without having to launch Harmony companion satellites, that would be much better.
I thought Roselle was going to use scan on receive, so it's not TOPS mode at all.
No, but there's still overlap. It's scan cell, but it's still have overlap.
If it's anything like NISAR, then it's complete. There's a lot of there's no burst, so it's continuous overlap. You can do MAI anywhere you want. There's no bursts to only have limited over.
Malcolm said it is possible.
Well,
No,
it's
it's
C-band, and then Roselle is L-band.
But then
NG is C-band. Yeah. So there'll be two C-band and then Roselle in L-band, all in the same orbit. So do we have any thoughts from our community about the orbits for those satellites? Whether we want, you've had your hand up a long time, sorry.
Yeah.
Go on.
Yeah, just I have remind that they say that regarding the tube in which the satellite goes, there is a trade-off between the size of the tube and the length of the mission because of the consumption. So we should keep in mind that if we ask for a shorter baseline, we'll have a shorter mission.
Yeah.
there's a cost always.
Tricky trade-off. Yeah. But they've extended the mission by being really slow in launching 1C and 1D.
I have a silly question on the north-south ambiguity and look directions. Is it possible to make an INSAR satellite that spins like a top as it goes across the surface? Or why wouldn't that work?
It's a recommendation for SDC.
Yeah.
One of the echoes had that.
We had a mission proposal called SuperSAR that had a forward beam and a rear beam. We've done that. But the overlap does it.
But I think it's quite likely if Harmony is successful that others will have companion satellites too. So we could have Roselle, Harmonies, and G satellite, and G Harmonies.
When is the Harmony launch?
2030.
28, they said.
I was going to say, I think, Katya wanted me to comment, but pretty much everything you guys said, right? So, Harmony will give you the multi-look, or multi-sprint, I should say. So that will give you the 3D. You could do spin like a top, but then, you will be spinning like around the equator in a sense, or whatever, so that, you won't get the global coverage, right? You could do veered orbits, but then it doesn't really get the routine coverage that we're used to from, sun-sync things. You can do inclined orbits, which I think Katya could talk about, and what's the benefit of those, at their coverage. Yeah, one nice thing I didn't hear too much expressed in this session is that the multi-sprint will also help with the challenge of troposphere, maybe. I don't know if we talked about that, but yeah, just some thoughts.
So on that note, I was wondering if anybody has any, since you mentioned it, has anybody thoughts about what's more important, whether it's global coverage that's important or it's improved measurements, and what if it's a trade-off? Would you like more localized coverage that is really fancy, maybe has 3D deformation and also has atmospheric removal and also has other things and frequent revisit or something like that? Or do you think that kind of continuity spatially and temporally is more important than that?
Well, as always, you ask both, but we
Since
want
you have a
everything.
mic.
I think it needs to evolve, so it needs to improve. So I'm not sure that are we seeing enough shortening in latency, shorter revisits times, and slight improvements in spatial resolution for the non-commercial satellites, that they can at least start to approach what is now possible with commercial SAR. Is the gap too big, and is it going to grow over the next 10 years, where we are working with a couple of satellites as a constellation that gives us more coverage, but at low resolution, time and space? And will there be a gulf with these commercial operators then, that we might miss out as a science community, that we can only do very small bespoke areas if we can get hold of the data, either through paying or with partnerships with these organizations? So is next generation, is it coming soon enough to give us meter scale SAR every day? I don't think it is in my career, and I'd
But I don't
like
think
it before I
commercial SAR
retire.
is going to do that either. It will do for your one area that you pay for, but they're never going to have the global coverage that we need for tectonics. We need all the tectonic areas at least, and we also need a background because earthquakes can happen in weird places. So I don't know.
Can I ask, what would be the orbit and the coverage and the revisit time after 1C and 1D launch? Because in the past, we only have 2 satellites, and then soon we'll have 3. How would that improve things?
So sadly, the plan is to park 1A when C and D are up there, so we'd only have 2 still. But recommendation should be not to do that.
But we will have NISAR. Okay, so recommendation not to park 1A until we're just dead. Okay, that's a good recommendation.
It's just about saving money.
I think a recommendation for Harmony would be to make it look really complicated. I know we can all do the suns in 3D deformation and what have you, but it would be much easier if that was done for us and we could get the level 3 products, whether quickly, so whether that's topography change or 3D deformation, and that was somehow done. So if we can recommend that there's some processing done so we can get those high level products.
Yeah, if I can add something there. So we're talking about gaps in coverage spatially and temporally. I think maybe the elephant in the room here is if Sentinel 1A goes down before 1C goes up. And Tim over there is grimacing a little bit. I think for obvious reasons this would have pretty big consequences, and maybe it's good to think in advance what impact this would have on different areas of research. Because, yeah, of course, the gap can be filled with some of the other providers, but then you're looking at different geometries, different wavelengths, and you've got a gap to fill over the entire world. So then some of these big continental projects are going to struggle if you ask TerraSAR for data over the whole Anatolian region.
I mean, we've kind of had that experience because we had, ERS and we sat on nothing for a while, right? Till Sentinel. Wasn't nice.
I mean, what was good was it gave you an opportunity to light some stuff up. Rather than carry on processing.
Okay.
I'm not going to write that down.
No, right, no.
Silver linings.
Yeah, I don't know whether there's a pre-deal that can be done with RadarSat Constellation mission or whatever so just as a contingency, so that they don't have to go into 6 months of negotiations before, in that.
They move pretty quickly when 1B.
But what to do what?
Oh, so they do cover the Arctic now.
Okay. Or whether they do tectonics.
Yeah, I think they shop things around.
I wanted to add a couple more things. In another meeting, we were talking about multistatic missions. It was highlighted that the simplest SAR modes are more companion-friendly than, StripMap is more companion-friendly than ScanSAR, TOPS, and so on, because then you need to sync the pulses. So I think if that is one way to push forward the science, multistatic, that might be something to note also, to make it easier for companion satellites. And then the other thing I wanted to add was earlier you were talking about commercial systems collecting background acquisitions before disasters. So one thing maybe we as a community can do is guide them and say, hey, over this volcano or over this fault zone, this is a typical declaration we expect for X-band, so please collect it by, every so often. And then that would give them both an area to prioritize and also how often they should target that.
So we're asking them for routine coverage of certain specific areas.
We may not get it, but the asking is free, right? So.
Yeah, along that line, I know the Polar Group has an organization to consult with the space agencies as a group, and we don't have that. We don't have like an advocacy group. But maybe we should form something like that.
That's a good point. That's a really good point.
Yeah, I think when they designed the tectonic area mask for Sentinel, it was basically, they talked to us, and we informally talked to some other people, and we came up with something that seemed sensible and then adjusted it where needed. But if we could do that in a more formal way, more inclusive way. Yeah.
That's a job for us.
Yeah. They could give us some money to do it. It's another one of those boring jobs, isn't it? But important.
Not as boring as comparison.
Are any of the upcoming satellites dual
I'm not going to live that one down.
Sorry?
Are any of the upcoming satellites dual band?
Just nice.
Okay. Can we tell NISAR, look here with this band, don't use that band, it's going to be garbage?
Too late.
That ship
And
has
then
sailed.
switch when it's in this region?
I don't think we can do that anymore. Well, maybe we can. Maybe we can't do it. We have to we just tell them when to turn on a
Exactly.
band.
I mean, are they going to
I mean,
do both of them? the
In
whole
some
time?
regions, no. Only in select.
Right.
It's all decided, I think.
Won't
I don't
they?
think this-
They will. Yeah. Yeah. Yeah, that's true.
I think there was in the opening presentation, there was a mention of this, the fact that they have, because of our request for this community, the INSAR community overall, that the acquisition schedule is very boring.
Mhm.
And I think we should reinforce the fact that we support boring acquisition schedules. It's
And,
really
and
important.
research.
But boring, important. But the same again and again, long periods of the consistent.
Mhm.
Well, it's boring for the engineers, isn't it? It's fantastic
true.
for us.
Yeah.
But
Engineers like more fun.
they like to
things,
tweak
yeah.
things, but we don't want that. Pick one and stick with it.
This is a great conversation. Any other suggestions? We have other questions that are geared towards, for example, disaster response. So we're talking about things that we would like to have for our research. How about we switch a little bit and talk about what we need for disaster response? Is that the same? Is it different? Do we want something else? Same stuff?
We did sort of touch on it, didn't we, earlier?
Yes.
Reduce latencies, more
We did,
satellites.
Cheryl and Lynn, those are the guys who worked at the front line of generating the maps. Do you have any complaints, suggestions?
I'm curious, who predicted the casualty and then how? So, yeah, based on your map.
So we always try to stay on a comfort zone of producing first raster image rather than jumping into creating information. And then we started creating a shapefile, which is vector. It's easier for geospatial community to overlay and produce number of people affected. It's partly because the world population density data, they evolve quickly. So if we just host it, it becomes dated quickly. So you want to always tap into the up-to-date, the latest data set. So that requires additional bandwidth to pay attention to with limited number of people working sleeplessly, tirelessly. And usually the user side, they are usually a GIS team. And they know what is the most hip, most accurate population density or infrastructure. So we tend to leave that part to the GIS team, users GIS team.
Unfortunately, somebody looked at the schedule, so otherwise we could have stayed here forever. But maybe let's wrap up. I think we've covered most of these questions at some point, one way or another, and let's just see if there are any other recommendations that have not been mentioned regarding data, missions, workshops, anything else that you can think of that we can make recommendations about.
I didn't hear the word license. For disasters especially, I think licensing is important, right? That the data gets out for openly and in a very short time frame so that
Right.
where was it?
So what we produce, for example, always put in the public domain. It's open and free. For that reason, it's actually not the best business model. It's very difficult to sell products for disaster response. One thing I wanted to mention is that we used to have easy access to Cosmos SkyMed, which is has a very low latency system. But unfortunately, we lost connection at some point. I know why, but afterwards, I didn't make great effort to reconnect. But I don't know if you happen to have some connection to ASI or maybe it should go through civil protection. If we can reconnect to Cosmos SkyMed data access, I think it will be really helpful to reduce latency.
So regarding datasets, some people were using data that was quite old on the one hand, and on the other hand, with high probability, the satellites takes military sensors. So could we ask ESA to push the military to release old data that could be useful for us and not yet useful for them? Because everybody else died already, for example.
Sorry, push them to release what data? Military. Yeah. It's kind of happened with GPS, right? Eventually.
Yeah, I want to touch up on Sentinel next generation a little bit because ESA is really in the discussion what to put on that mission, and they are talking about having water sensors also and radar sensors. So it's of course very important to have the continuity, and maybe we can have a more overlap to get more north-south. But I mean, what about a mirrors type of instrument? I mean, it can really help to beat out the noise when it's not cloudy. And I think this is maybe something that, or we should at least start to think about. I mean, if they're in the process of potentially putting more sensors on the satellite, what would we like in addition to the radar? So, and now is the right time because they are still in the kind of, well, they're not even in the design phase yet. I think they're just kind of bringing things up. Yeah.
So I think that's a very good point. Could you remind us exactly how? I remember Maris was very useful.
Yeah,
how
I mean,
it was
you
useful?
can get a water vapor estimation from when it's cloud free, and it really greatly helps to beat down the turbulent troposphere in cloud free areas where you have still a lot of humidity and turbulence. So it is. You were smiling.
I just said like Saudi Arabia,
For example.
Not Singapore.
Yeah.
Oh, yeah. Singapore if it's not cloudy.
Okay, that's a great question. Anybody have any opinions on other instruments we could put on satellites? It's already a pretty good comment, but
Speak now, I might say we could improve your visit time. A way to use INSAR and disaster monitoring, policy protection.
how much to improve it? 1 hour?
Oh, this,
Every 5 minutes,
So-
everywhere. Sorry.
I think this geosynchronous SAR would do that.
Mhm.
So you would,
Um,
but you'd have to, yes.
Maybe addition to
What's the orbit time for Sentinel? No, not the repeat pass time, but the time it takes to circle the Earth. 90 minutes? Yeah, so just say hardest starboard, and just get it to, get it to go to the place.
That was short.
Just one more point with Sentinel. If Sentinel-1A will still be alive and C and D come up, I mean, where do we want to? I mean, they put them. I mean, C and D are going to be like A and B in a 6-day orbit, right? So what? But then we have Sentinel-1A. Would it be good to have 1 day or 2 day or a mix? If it was a 2 day, then can be a 2 day and 4 day and.
And I think the same would be Roselle with the 2 Roselles. You know, if you've got 2 Sentinel with the NG, you've got the NGs and the Roselles. I think my gut feeling is we want them evenly spaced, but I don't know whether other people agree.
Because then eventually, if 1A dies, but then you have like C and D kind of not evenly spaced, it might be.
No, they can be 6 day apart, but then A is there, so I mean we can adjust it with respect to A, the 6-day cycle.
Good question.
I don't know what the tectonics community would like. I mean, I think it would be interesting to have a possibility of having 2 day and 4 day, and, if Sentinel-1A is still alive.
Maybe get more of this biased estimated by using, you get a 1 day pair, you get some different lengths. You could maybe get the bias from the difference between the 1 day and the 6 day.
Yeah, I think having 1 day is quite beneficial. I also think it may be that having Roselle 1 day behind might be more helpful for estimating its effects as well.
Yep.
But then the tropospheres would be correlated more.
All right. Any final recommendations? Because people, I think, want to. Okay. We don't have to go anywhere. We just stay here.
To the point of evenly spaced satellites, it's always a compromise. But I also would vote for something where we can make discoveries, which would be something shorter, like 1 day or so, for very fast processes that we can capture every now and then. I think this could be very exciting.
Yeah, so if we want to make a case for them not to park it, maybe it's actually helpful to have some new.
Yes.
And maybe they don't have to take data when they're not pointing it at something if they want to save cost.
I think the ice community wants a 1 day repeat also, because the ice moves too far in 6 days.
So is that a feeling we're relaxed about it as a community? The potential interest of 1 day there, because we're not against it. Yeah. Good.
Okay. Okay, if there are no other comments, you guys,
The
I'll
ETAT
let
thing,
you
you
guys
could write
go.
down that we want them to do ETAT for everything,
yes.
but they won't.
I thought we kind of, already voiced that sentiment, which is why I skipped over. Yes. Anything else? Any other comments from the leads, the chairs?
Do we want specific format for ETAT? Whatever they produce.
Easy.
Don't change it.
Easy for
Yeah.
Which ones? Which edition?
Keep the raw data, keep it uncorrupted.
Oh, I see, okay, got it.
Or
Quick one. So she showed that she gets very strong signals from both her area. You can see that the land cover affects signals like fading signals and whatnot. Is there any effort from ESA to put like a unified land cover mass so we can start to correlate these things without to go through each people's individual works, or sometimes just go backwards?
I was gonna ask the same thing for, can we predict landslides before we get the repeat pass and set up a preliminary disaster response model? But Jack's question first.
So is the recommendation to provide, let's say, a land cover map as a layer in a data set? Is that what you think would be useful?
Yeah.
Okay.
Yeah, I guess so. Just something where we could potentially start to see if we can correlate any of these signals that we are seeing to the land cover.
well, there is a Copernicus land cover map already, isn't it? I mean, it's available.
There's no global ones though, are there?
Yeah.
Oh, well, in that case, done.
I mean,
Could just
they
check it
don't
on the
always
list.
correspond to the sort of inside behaviour, so it might be the one that was informed by coherence and things might be interesting.
Group at, what's his name, published a global coherence map from Sentinel-1
Yeah.
a couple months ago. So it exists.
Okay. Meeting adjourned. Thank you.